Newton's first law. An object in motion will stay in motion, and an object at rest will stay at rest unless an unbalanced force is acted upon it. The magic carpet ride is a great example of Newton's first law. Newton's first law is also referred to as the law of inertia. When viewing the magic carpet ride, it starts to move really slow. This is because the object is at rest. As the ride continues, it starts to become faster. As it tries to spin the other way, it slows down, stops, slowly spins faster, and then continues to pick up speed the other direction. The people inside the car are also experiencing inertia. When spinning, the people continue to move forward as the ride continues to turn, causing people to lean to the side. As the ride comes to a stop, it starts to move slower because the object is now in motion and is being acted upon by an unbalanced force to come to a complete stop. The hula hoop is an example of Newton's first law of motion because the object, the hula hoop, is at rest and doesn't start to spin until my hand pushes the hula hoop. From there, the object doesn't rest until gravity, or in this case my hand, acts as an unbalanced force. Newton's second law. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. In other words, force equals mass times acceleration. An object accelerates in the direction of the net force. With more force, there is more acceleration. With more mass, the acceleration will decrease. An example of Newton's second law is the desert storm. The force applied to the roller coaster is caused by the mass of the roller coaster and how fast it accelerated. The roller coaster accelerates in the direction of the net force. When the roller coaster reaches the top, it is pulled down by the force of gravity. The more people on the roller coaster with the same amount of force applied, the less acceleration. When the roller coaster is about to drop, it is accelerating towards the net force, gravity, making the acceleration faster. Flipping tires is an example of Newton's second law. The amount of force that is exerted depends on the mass of the tire and the acceleration in which it is flipped. The tire is accelerating in the direction I pushed it. The more force I push it with, the quicker it will accelerate. The heavier the tire, the less acceleration. This tire was 400 pounds. Unlike the first 200-pound tire, there was too much mass with zero acceleration, so there was zero force. Newton's third law. For every action, there is an equal and opposite reaction. The ramrods are an example of Newton's third law. The ramrods clearly show Newton's third law. When he crashes into the side of the wall, he exerts a force on the wall, and the wall exerts a force back on him. Since the wall has more force, it pushes him back. My brother and I showed Newton's third law within our handshake. At the end, we bumped into each other. This action had an equal reaction of pushing us together and an opposite reaction of bouncing the other way after. This project has helped me develop a deeper understanding to how Newton's laws apply outside of the classroom. Little things such as jumping up and down to riding on a roller coaster, Newton's laws are overlooked. The end.